Persian Dete, good morning. Thank you for coming to this talk. And today we'll be discussing building bots for Java games, a beginner's guide. Before I start, one common pattern you'll see throughout this talk is me tying it back to security somehow, as this is a security conference at the end of the day. So moving forward, here's the agenda for today's talk. First, we'll talk about the disclaimers. We'll introduce the game that we're writing the bot for. We'll talk about some of the techniques we'll be using, and finally, we'll get into building the bot. So, quick disclaimers. As we are writing bots, the legal territory is questionable. So, whatever you learn here, just do it at your own risk. And I don't do this for my day job, so this is a pure hobby of mine, so it's not affiliated with my employer in any way, shape, or form, if my employer is listening to this talk. So, let's start off with a meme to kind of lighten the mood. So, some of you may have seen this meme. It's how to draw an owl. So step one, just draw 2 circles, and then step 2, draw the rest of the owl. So the purpose of this meme is to kind of convey the challenges that speakers face when talking about, such dense topics as this. You can break a lot of the topics in this talk out into their own sections that will be hours long. Though my goal is for this talk to be of all levels, and while you may not understand what is happening under the hood, you will understand, while you may not understand why we're doing something under the hood, you will understand what is happening. So let's introduce the game. So the game that we're going to be working with is Runescape. Some of you may be familiar with this game. If not, I'll give a quick TLDR. So Runescape was released in 2001. It's been regularly updated to this point. In fact, 10 years ago, it was split into 2. There's the more modern version, which has, what you expect of modern games, such as graphics and, gameplay mechanics. And there's the old school version. So RuneScape itself is point and click, meaning that to interact with the game, you basically point at the screen and you click what you want to do. So for example, if you want to interact with the monster, you click on the monster. If you want to interact with the player, you click on it. This is a little bit different from your typical games where you use the WASD keys to move. While in RuneScape, the only time you really use the keyboard is to move the camera or to speak with other people, or I guess type to other people. So the reason it's actually point and click is the history behind RuneScape is that it actually started off as a browser game. And that's what gained so much popularity is because back then you could actually run it on low-end machines and have a fully fledged game in the browser. Typically you have these browser games which are just like mini games, but this is an actual full MMO in the browser. And this is where it gained its reputation as being the game where people played at the library or people played it at school. The game itself is written in Java. There's an asterisk because the old school version is written in Java, while the newer version is obviously written in C++. And the game itself follows the client-server architecture pattern, meaning for every one server, there's many clients. But the quick caveat is that we're actually not going to be writing a bot for the real RuneScape. We're going to be writing a bot for what's known as a RuneScape private server. So let's talk about what RuneScape private servers are. So RSPS is an acronym for RuneScape private server. And really what it is, it's a version of RuneScape that's not ran by the official developers, but rather individuals who basically reverse the game and were able to write their own version of the game. It typically features custom content and a different style of gameplay. So that's what makes these games so alluring is that, for example, in RuneScape, it was one of the first, I think, concepts of a freemium game, which means that it's free to play, but eventually you hit a paywall. And if you want to continue, you have to buy membership. The difference between RuneScape private servers, though, is that typically they would actually give you all the membership content and all the features for free. The revenue model was a little bit different in the sense that you could pay for like custom items, because people value exclusivity, and as proven by NFTs in the recent past, people want to have one of everything. There were lots of different private servers, actually they've been dying recently, but in the past there have been thousands. On the left you see some of the more popular private servers back in the day. Some of these are from 2007 all the way to now. And so RuneScape itself had, I think, around 100, had actually hundreds of thousands of players. But the difference between RuneScape and RuneScape private servers is that private servers actually only had around 1,000 players. But the games felt more populated because RuneScape would split these players across different worlds. So you would have maybe 100 worlds with 1,000 players on each of them. While in RuneScape private servers, you would only have one world with 1,000 players. So you felt, it was a lot more dense. And last but not least, there's different revisions, aka versions of RuneScape private servers. So a revision is a version of RuneScape. So for example, maybe you like the version of RuneScape in 2007, maybe you like it in 2009. So that's what's known as revisions. So moving forward. So let's discuss some of the techniques we will be using today that will allow us to write the bot. So first and foremost is reflection. So reflection is in other languages. So for example, a language may have its own variant of reflection. So Golang, Python, Ruby has reflection as well. Basically what it is a technique allowing runtime inspection and manipulation of objects, methods, and fields. Basically what this means is that while the program is running, you could get the value of whatever you want at the current time, and you can actually modify it. Reflection has a close cousin called introspection, and I think introspection is what Python has, is basically while you're not able to modify the value, you're able to actually see the value. You'll see reflection commonly used in frameworks and libraries that deal with, serialization, testing, and, stuff along those lines. One limitation to note about reflection is that new logic cannot be introduced. What that means is that I can't inject entirely new logic into the client. So I can only use what's there. And this will come in handy later. And last but not least, reflection may cause some performance overhead. So really based on the number of values you're trying to access with reflection, the performance, the more you're trying to get, the more it can impact your performance. And an extension of the last point is that anytime you use reflection to access a value of something, you're only accessing the value at that current state and time. You're only getting that state at the current time, meaning if the value does change, for example, like a player's health in the game constantly changes, then you'll have to use reflection to retrieve it again. So you're basically having to keep constantly reusing it. And reflection will be the technique that we actually will use to write the bot today. So here's an example of reflection. So in the first case, you see that we're instantiating an instance of the runtime exec class. And what this will allow you to do is just execute execute a command. And as shown in Rio's wonderful talk yesterday about hacking Cobalt, if you took a close look, Cobalt actually uses reflection to instantiate the objects, the arbitrary objects that he would pass using the object HTML tag. So let's talk about where you may see reflection in the real world. So if you've ever had to deal with leveraging deserialization in Java, you may have most likely used the tool called ysoserial. If you're not familiar with ysoserial, it's basically a tool that you can use to generate deserialization payloads that, when evaluated by the target, will result in active exploitation. So here's a gadget for Commons Collections 5. So Common Collections is a popular set of library published by the Apache Foundation that just adds utility and helper methods to Java. And so the one thing you should note about here is that on line 6, we're instantiating an instance of the bad attribute value exception class. And then on line 7, we're getting the declared field val. You can see there. And then finally, we're setting a value using it. So you may be wondering, why are we using reflection to do this, right? It's a little bit of an overkill, it seems like. Well, if we take a closer look at the actual class definition of bad attribute value exception, you'll see on line 11 that the value actually has the private modifier, meaning if you're familiar with object-oriented programming, it means you're not able to access this value directly, and this value can only outside of this class. So the value can only be accessed inside the class unless there's mutator methods like getters and setters, but that's out of scope for this talk. A second technique we'll be using that you will commonly come across is called instrumentation. So what instrumentation really allows you to do is add new logic to whatever you're instrumenting. And like I mentioned earlier, one of the limitations of reflection is that you're only able to reuse existing logic. While here, you're actually just able to add any arbitrary logic you want into the application. So instrumentation is commonly used for monitoring, tracing, and profiling. So for example, if you want to, trace, trace the metrics of your app, how long does, a specific method run, for example, you will be using instrumentation for this. You'll commonly come across this as called injection, because you are injecting code, essentially. And one of the most popular forms of instrumentation are actually Java agents, which itself is another topic that can have its own talk. And basically what you just need to know is that you're able to attach a Java agent to an existing Java program, and it's able to inject into that program. And in our case, the most common use case to use instrumentation is to inject mutators such as the getters and setter methods. So for example, if the class has a field that's only private, we can inject a getter method that can now return that object. And one last thing to leave off about instrumentation is that it's typically faster than reflection. And that's because when you are injecting getter and setters, you have direct access to the fields rather than using reflection to get them. And so today we actually won't be demonstrating reflection, we won't be using injection to write the bot due to time constraints. So let's examine a real world example of instrumentation. So hopefully everyone can see this. So, oops. So basically here's a basic Java program. All it does is print hello besides Pristina to standard out. And let's see the code, let's see it run. So here we are compiling it and we're running it. So right, like I said, it's going to just print besides Pristina. And I ran it twice just to show you there's nothing happening under the hood. So now let's look at the agent that we're going to use. So the first thing you should examine, the only thing we're going to use with this agent is we're going to connect to the main method. And then what we're going to do is insert the last line, goodbye Pristina 2023. And we prepend this agent tag to it just so you can, for visibility, just so you can see that this is the agent that's actually doing it. So, and then obviously then it manipulates the bytecode and all that stuff. So let's run it. So actually now I show the original code again. So this is the main method that we're going to be instrumenting, and we're just going to insert that system.out.println goodbye besides Pristina. So let's do this. So here's how we run the Java agent. We pass it an argument called Java agent, and we point it to our agent. And as soon as it executes, you now see it insert goodbye besides Pristina 2023. And I think I'm going to run the original oh no, that's it. So that's an example use case of using a Java agent. So let's get into building the bot. So what is the client itself? So the client is a picture of it you see to the left, and it's essentially a graphical user interface that the player interacts with in order to play the game. So if you think about it in a way, the client constrains what the player is able to do and what they're not able to do. And what I mean by this is that, for example, if the player doesn't have an item in their inventory, they're not able to equip that item. Or if the player is not able to, the view distance of what they're able to see, if something's happening far off, they're not able to see that because they're only able to play the game the way that the client wants them to play the game. And because of this, the client can be thought as an intermediary, basically a middleman between the player and the game. So let's talk about, oops, I didn't realize it was not in full screen. So let's talk about let me provide an analogy that maybe a lot of people, some people may understand, is that essentially the browser, like your web browser, is a client, and the website that you're interacting with can be considered the server. So in the same sense, the browser comes with the engine, which is able to render JavaScript, and because of that, you're now able to have client-side code. And what's happening is, for example, there are cases where the client side is able to control how the user is able to interact with the website. So in this example, this is a simple HTML form, and basically it has one input field, and what it does is before the user submits the form, it'll check if the input field has a single quote. And basically what this is the ultimate SQL injection protection, right? Who needs sanitization or prepared statements when you can do something like this? Because if we're talking in the sense where the client has full control, that means the player, like in Runescape, they're not able to directly interface with the server. They have to go through the client. But just like many of you may know, so here's an example, like where I type in test with a single quote and it tells me single quotes are not allowed. So would this protect against SQL injection? No. And that's because what you're able to do is maybe use a lower level, like curl, for example, which doesn't support JavaScript, to send data directly to the server. Or if you really wanted to, you could just send raw HTTP requests. You can get really, really low on how you get around this. And we're actually going to be using this to be able to interface with the client, or sorry, interface with the server. And just like with any other client-server communication that exchanges user input, always trust but verify the data. So let's talk about how the actual Runescape or Runescape private server client works under the hood. So the game itself is a Java applet, which is bound to a JFrame, and the JFrame itself is a container which contains all the interface components of the game. So you like your health, for example, it draws the sprites in it. And so here is and last but not least, the JFrame is also able to receive events such as like mouse clicks or keyboard input. And so here's an example of how it may work under the hood at a very simplified level. So within the client, I want to equip an item. So in this case, a Santa hat. And what happens is that a listener is invoked when I click it, which then processes the action. It checks, hey, what action do you want to process? Each action has a code associated with it, an integer. So in this case, it's going to be equip item. And then it's going to run a series of checks. First, it's going to say, okay, if you want to equip the item, we'll remove your item from the inventory, and then we'll update the player's appearance to show the equipped item. What's actually happening is before these checks are ran, the client sends a packet to the server, and this is how the packet structure looks like. So the first value here is the opcode. So opcode 41 means equip item. The second value is the item ID. So what item do you want to equip? So in this case, the item ID, you may see it here. It says 1050 right there. And then the last two values are not important. It's just basically the interface ID. You can ignore them. And what happens is the server receives that packet. It then says, okay, the player wants to equip the item. Cool. So then we're going to perform some checks. Does the player have an item in the inventory? Can the player wear the item? Like, you know, maybe there's some stats associated with the item that the player may need, like requirements. And if so, okay, cool. Let's send the packet back to the client telling everything is okay. And now we'll update every other player to show that you've equipped the item. So let's talk about some of the layers that we'll be writing a bot for. So we'll be writing a bot for each of these layers today. So you may have heard the term, if you're familiar with game hacking, you may have heard the terms of external and internal in the context of C++ game hacking. It's not the same here as in like using write process memory or read process memory for external or injecting a DLL for internal, but rather what external is we'll explore each of these avenues, but just understand that we'll be working on 3 layers. So let's actually start with the last layer, which is the packet, aka the network layer. So this bot will be known as a headless bot. So let's kind of talk about what that means. So a headless bot doesn't have a graphical user interface, and because of that, it's able to run on machines that are lacking desktop environments. And typically these machines are like Ubuntu servers, Windows servers. And due to having no desktop environment and no graphical user interface, this will actually conserve resources. Even if it's a 1% performance improvement, you have to remember that majority of people who write bots are typically using it to make like money, and they're known as gold farmers. So, and that means they're running like maybe thousands, if not tens of thousands of bots. So if you extrapolate a 1% performance increase across, several thousands of bots, it can actually make a big impact. The one thing about writing headless bots or network is that you need to have extensive knowledge about how the client operates under the hood. So, for example, if the server sends you a packet of 41, do you know what that means? And you really need to understand what's going on. And one of the beauties, though, is that you can write this in other languages. So it's interoperable. Since you're working at such a low level, like you're working literally with bytes at this point, you can write it in any language you want. And to prove this, let's actually before that, here's how you would originally log in using the client or the graphical universe. So notice that first you click there, then you type in your username and your password, and then you click login. So this can be considered very manual and tedious if you're trying to run thousands and thousands of bots. And the reason for this is first and foremost is that copy and paste is disabled. So you're not just able to copy username and password, and you have to click twice as you've seen. And one of the other things that we'll talk about is that the client, in this case, like I said, it has constraints, and you're not able to use special characters apart from alphanumeric, which are forbidden. And this will become important in the next slide. So let's see what's happening. So we just saw the login happen. This is what's actually happening under the hood. So in red are the packets that the client sends, and in blue are what the server sends. So you see that the client sends, I think in 14.0x0e, basically telling the client, it's like a magic byte to start the handshake. And then the server sends back a sequence of bytes, and this is the server key. And then finally, the client sends back a large buffer, and finally, the server sends back a response. And one thing you should notice about this large buffer, you may not see it, yeah, the big buffer right here, is that there is no you don't see my plaintext username or my plaintext password. So my username was Maxim and my password is Maxim. You don't see that here. And that means that some form of encoding is happening under the hood. So that can either be compression, can be encryption, could be both, could be something entirely else. In a lot of cases, for games like this, login handshake is already documented by people who've already reversed it. And if not, just take a look at yourself as what's happening in the code. So we'll see the code here on the left. Don't worry if you can't read it. It's not supposed to be read. But rather what's happening is that the TCP is used as the transport mechanism to send data between the client and server. ISAC is actually the cipher used for encryption. And if you don't know what ISAC is, sorry. So, sorry, as I was saying, ISAC is used the encryption cipher, and the way it works is that the cipher is seeded with a combination of random values generated by the client, and it's concatenated with this server key that's sent back by the server in the original handshake. And then the seed and the credentials, so my username and password, are exchanged using RSA, and then between the client and server. But as I mentioned, ISAC is used the encryption cipher, so where does RSA come in? So stream ciphers such as ISAC are typically way quicker than something like RSA, which is compute heavy, especially if you're having high data throughput. So if this handshake looks familiar, it should, because this is actually how TLS works under the hood. So the way TLS works is essentially once the client will use RSA to send an encrypt random value using the server's public key. It will send that value to the server. The server will then decrypt that value, and then finally it will then they will switch to another encryption algorithm that's a stream cipher, most likely AES, and then they'll be able to encrypt and send data back and forth to each other. So, like I mentioned, we're able now to basically write this login handshake in any language. And something that can come out of this is actually a login brute forcer, for example. So that's one of the security impacts. So here, I'll play the video. So basically what I did is I implemented the logic in Golang. And so you can see here, basically, I'm just quickly scrolling through the code. And again, you're not really meant to read and understand the code. Basically, what it shows is it sends a login request. One of the most important things that I'll highlight here is showing using the server seed. So one of the things that I noticed that this server in particular did was that it never verified that the server seed you send it is the one that it sent you. It's not really a security impact. It was just kind of interesting. It makes it way easier to write this. So essentially what this is happening is now it's going to try a username and passwords and try to brute force accounts. And one thing is, look in the bottom left corner. And the reason I say this is because if a login is successful, you'll see it say player has logged in. So let's try. So it's attempting to use the credentials Sparkle Gem 79 with the password Maxim. And if you look in the bottom left, it says a player has logged in. And therefore, we know it's valid credentials. And it keeps going through until it eventually it exhausts the word list. Cool. Another thing you could write with this is server flutter. So essentially you can, flood the server with a bunch of arbitrary logins and fill up the queue and prevent legitimate players from logging in. And as I mentioned earlier, you're now able to send the server unexpected data. So for example, the client didn't allow you to use alphanumerical characters in your name. Well, using this way, we're able to send the server whatever we want. And what if during the login process, there's a bunch of SQL transactions happening under the hood? Well, if there is no, form of SQL injection protection implemented, you're now able to, potentially leverage something like SQL injection. Or another use case is, for example, now what if you send the server unexpected data that it doesn't know how to deal with? This can result in a layer 7 denial of service, essentially crashing the server. Oh, sorry. Looks like every time I go into full screen. Cool. Let's move on to internal bots. So internal bots are really achieved using reflection, injection, and a combination of both, which is why I showed you a quick TLDR of each in the earlier slides. The cool thing about internal bots, it saves you a lot of time because you're able to reuse existing code. Like I mentioned earlier, like with a packet bot or like one that works at the network layer, you really need to know what's happening between the client and server. Well, in this case, you're just able to reuse existing code and see what's happening. And typically, this is the most popular form of bot written for Java games because of the reasons above. So let's talk about what Client.java is. So a lot of Runescape drivers follow very similar boilerplate. And the reason for that is because the majority of people who write these servers, their whole intention is to, my apologies. Their whole intention is not to really, because the game itself works well. So really what they're trying to do is add custom content. So they're not really trying to change anything under the hood. So you'll find the majority of servers will follow the same boilerplate. And the Client.java itself is, you can think of it as a centralized component that works as a controller. And what you'll see to the left here is a bunch of values declared that hold references to objects of interest, especially if you're writing a bot. So to the instance of your local player, NPCs, other player instances, as well as like the current player's location, and so on. And the client class itself inherits from the GameApplet class, which you can see right here on the first line, extends GameApplet, which in turn inherits from the applet class. So the client is able to be cast as an applet. And if you're not really familiar with what I just said, don't worry about it. It doesn't make a big difference until you actually start writing the bot. So let me show you how we'll use reflection to write this bot. So first and foremost, we have to discover how the real client is scaffolded. And what that means is how it's built. So in red, you'll see here it says original client, which means this is the code from the original client. So first and foremost, we need to find the main method, which is invoked whenever a Java program is started. So we see what happens, and for context, this main method actually lives in Client.java, which is why I mentioned it's such a vital aspect of this whole process. So you'll see the first things that happen is that we assign a value of 10, we initialize the node ID field as a value of 10, port offset 0. None of it's important. And, essentially you see a call, well, it's important if you're writing the bot. It's not important in this case. It calls a method, and then, it further goes on, and finally it instantiates a new instance of the client, and then lastly, it invokes the create client frame method, passing in the frame width and frame height on the instance. And the reason this is important is because we'll need to replicate this process using reflection. So let me show you how that would look using reflection. So this is our reflected client as denoted by the green text here. So first we get the client class from the class loader. We then grab the constructor from this class, and the constructor is the method that's executed when you instantiate a new object in Java. And what we do is we instantiate the applet. Whenever you use reflection to instantiate an object or get a value, it'll always return the object of type object, which is a generic object in Java in which every object, I keep saying object, I'm sorry, inherits from. And we then cast it as an applet. Because if we never casted it, it would just treat it as an object, and we wouldn't be able to have all the methods that the typical applet would have. And lastly, like I showed you earlier, you can see the node ID set to 10 here. Well, this is how we would do it in reflection. We use reflection to get the node ID declared field. We set it accessible to true. If it's private, I don't remember if it's private in this case. It doesn't make a difference if it is, and you just call it. And then finally, we set the value. You see 10. And the first argument we pass in is actually the class itself. And then we do the same thing with the port and so on. So you can, if you look back and forth, it's basically we're doing everything the same up to here, this part. So now let's examine how this part works, line 10 and 11. So line 10 calls create client frame, and the create client frame method lives in the GameApplet class. And the GameApplet extends the applet, like I mentioned earlier, so it inherits from applet. And you see it implements a bunch of interfaces such as like mouse motion listener, mouse wheel listener, and this is what allows it to receive events. So if you click something in the game, you're invoking the mouse listener, for example. Or if you move your mouse, you're invoking the mouse motion listener. So that's why it does it. So let's see how the create client frame works. So again, it does similar stuff. It assigns a bunch of values or initializes a bunch of values. But one important thing, what it does is it instantiates a new game frame. And let's look at this game frame class. So the game frame inherits from the frame. So this is itself a JFrame, an extension of a JFrame. And first thing it does is initializes the applet. It then sets the title of the frame of whatever is defined in the configuration file. It sets the resizable. It sets whether it could be full screen. And then finally, it set visible as true, so you can actually see the frame. So now let's see how we would do this in reflection. So what we need to do is use reflection to get the create client frame method. And then what we do is we invoke it on the applet that we instantiated earlier. And one of the interesting things what we could do is now that we can access the game frame field from the client. And what we do here is you see we use reflection to grab an instance of it, and we set the title of the frame to B-Sides 2023 demo reflection client. And exactly.
So that means that this bot will be shown as an applet, or it will still be run at the console. So you can run on a system with no GUI interface.
No, so that's a good question, and I should have mentioned this. So this will actually invoke the GUI. So what we do is we take over the GUI, and now we have full control over the GUI. So this is you playing with the GUI. And when I mean internal, basically it means you can access the internal code that the client encapsulates. So if the client has like a method you want to call, you're now able to do that. Because before when you click the GUI, it locks you out. Like the GUI runs, and you can just only, play with it as a game. Now we have full control of it.
Okay. Okay, thanks.
Thank you for the question. So like I said, we set the title, and if this is successful, now you see the client load, and now it has B-Sides 2023 Demo Reflection Client as the title. So with the applet now under our control, we can now achieve the following things. So first and foremost, one of the most important things for a bot is that we can read and modify values that will influence gameplay. And when I mean influence gameplay, for example, now we can read our health. If our health is lower than a specific threshold we set, we can now eat food or drink a potion, whatever the case may be. If we're fighting a monster, now we can see, hey, we're fighting a monster. What's the monster's, health level and stuff like that. We're able to call existing logic defined in the code. So there's several helpers spread throughout this project, throughout the code base, such as like the send packet method, which basically does exactly the same as our internal bot does, but at a higher level. So now instead of having to send raw bytes, we can now call a helper with some predefined opcodes that will be able to achieve the same thing. And this is what I mentioned by reusing the code in the earlier slide. Finally, we can simulate interaction in the client, such as sending mouse events to mimic clicking or key events to mimic keyboard inputs. And this is important for a bot because at this stage, you have two ways to use the bots. You can still be sending packets throughout using the send packet method, or you can be actually using mouse events in Java to simulate clicks. And whichever you use is up to you. Both of them may invoke some anti-cheat, but again, there's no anti-cheat in this server. So let me show you some of the things we could do with reflection. So here's a funny quote, dance is the hidden language of the soul. And so what you'll see here is my client and my click player, and you'll see that here are some non-playable characters like NPCs. And on the left here is a J shell, and what that basically means is you can think of it as like a REPL or an idle, or like Python's idle, or Ruby's IRB. We're basically able to execute code in the context of this. And the way you get the J shell to work, and this is not in scope for the talk, is basically J shell is launched into its own isolated process, so you have to share the class loader. And again, if you're not really too sure what that means, don't focus on it. You can always look it up later. In the bottom left, here's the code that we're going to be executing. So first, we get the NPCs field, which is defined in the client. And you see that it's private. And means it has the private modifier. So then we call setAccessible true on it. Cool. And finally, we get the actual NPCs themselves, which returns an array of NPCs. So you see a bunch of them are null because the array is a predefined size, but some of them, you see some instances right here because these are these guys' instances. Finally, we'll iterate through each NPC and we'll set an animation. And now we can make them all dance. So we have like full control of the client. Take a sip of water first. So let me show you excuse me. Let me show you something else we could do. So another quote, the only way to do the impossible is to believe it's impossible. So in my case, I want to run through walls in the game, but the game doesn't allow me to run through walls. So anytime I click, you see it automatically paths me across the wall. And what we could do is what we do very similar to what we just did in the last slide, is we grab the collision maps, we set them to accessible because you can see that they're private. We grab the field, and now we actually grab the actual collision map, so you can see it's an array of initialized with the collision maps, and we'll iterate through each collision map, and we'll basically set it through 0. So now I'm able to no clip through walls. And if the server didn't have any logic that will validate your location, you would essentially be able to no clip anywhere. And here I show that I'm able to no clip in an area that's in the bank that's never accessible to players. So those are some things we could do with Reflection. So it's essentially a bot and a cheat client. Like if you're familiar with the term cheat client, tread on the same line. There's a very, very minimal difference between what you could do with the bot and a cheat client, as shown here. So this no clip, for example, would be something you would find in a cheat client. Okay, cool. Let's move forward to external bots. So external bots. External bots are essentially, you may have heard the term pixel or color bots. Really what it does, it just reads data using pixels on the screen. So what this means is basically what you see is what you get. So what you see as a player is the same thing the bot would see. So for example, you could see, there's this interesting blog post about someone writing, a bot using OCR libraries and other image detection, such as like Tesseract and stuff like that. And what they were able to do is highlight like the rocks. So again, this is fully external. You're not injecting or manipulating the client in any way. This is running in a completely separate process. So it's common to find libraries. So you'll most likely find these bots written in Python because it has support for these kinds of libraries. Like I said, Tesseract, OpenCV, and etc. There's other software like AutoHotkey you may have heard of that, you can have scripts written that will detect a pixel on the screen. Simba, which is actually was built for Runescape. So here's what is actually happening under the hood with an external bot. We take a screenshot of a section of the screen. We pre-process the image. We use OCR to detect what's happening on, and then we take an action. So like, for example, if we're using health, and the action is our health is low, we need to eat food. We'll probably have another script running that's able to locate the location of the food on the screen and then send a click, and then it just loops itself. So let's take a look at what's happening. So what I'm doing here is, you may not see it, but my prayer level is right here. And this is, in the game, prayer is just used as buffs you can consider. And what you see here is I'm using a color bot that's basically, or a bot that's basically extracting the values of my prayer and printing it on the screen. And you'll see that it's really not that reliable. So like it prints Q1 or it prints something like 539 or 1. And again, my color bot is very, very brittle. It's very rudimentary. Usually you would use implement pre-processing and all this stuff to make it, like I'm saying, is that it's not as robust as internal bots, but some people make them really, really well. But to me, I find it a lot more hard. So another, something I just missed is that if I close this interface, for example, which you'll see me do right here, just missed it again, sorry. So basically what it does is that it reads this value. So if this interface is closed, it's not going to be able to read the value anymore. And I think I've shown an example of here. So there we go. I close the interface and you can see that it's not able to find the value. So that's why these bots can be considered brittle. These bots can easily be broken. So for example, someone once wrote a mining bot that would find the rock would be a specific color and it would just click on the rock whenever it would find the color. What another player found was they found another item in the game that was the same color. So they went around and dropping that item. So what happened was the player's bot just started clicking that item and completely broke and made it obvious they were botting. So last but not least, I'd like to leave off with a slide. So one essential fact that I didn't show you is that in the real world, the client's going to be obfuscated. And what that means is that the Java code, basically, in layman's terms, it's going to be scrambled. It's going to be hard to read, and that's done on purpose to prevent, people like ourselves from writing the bot. And if you're interested in this talk and want to actually see how you can, write a bot for an obfuscated client, there will be a blog post on my blog, hopefully by tomorrow, that will actually detail the process. So basically, we'll leave off from where we ended here and then use some de-obfuscation techniques to write the bot. And last but not least, here's some cool references you can look at if you are interested in this kind of stuff. And yeah, that's pretty much it. Thank you.
Max, thanks so much. That was so great. I'm not a gamer, but now I know how cheating is done. I'm kidding. Do we have any question for Max? There you go.
I can ask in private, but just for the sake of others. So you mentioned that when you instrument the client, you can walk through walls, and if I understand it correctly, that all happens in the client. Did you see any? So there's obviously going to be communication between the client and the server for some stuff. Like, where's that limitation where you talk to the server and I assume the server also has protections against some things. Like, where is that line? Did you find it, and what can you do when that happens? Thank you.
Thank you for the question. So good question. So when I showed everyone dancing here, for example, this is only shown on your client. You're not going to see, like, other players are not going to see everybody dancing. So this is completely client side. This though, when you're walking, when you're making any movement in the game, it's actually sending packets to the server telling it's your location. So the way you would implement an anti-cheat on the server, this is you would have a list of locations that you can potentially say, hey, the player cannot be here. And if the player is going there, then something's happening under the hood that should not be happening. And so anytime I walk in the game, anytime you click or you walk anywhere, it actually sends the location, your X, Y, and your Z coordinates, and Z is the plane, to the server. So lastly, I just want to thank my colleagues for coming out and watching my talk. Thank you, Spend and Spedem.
Thank you, Max.